This video will help you with section 4.2 with finding real zeros and factoring a polynomial function. We'll just get right to examples here. So I'm giving you the function x cubed plus 2x squared minus 5x minus 6. And they're asking us to find the real zeros of f and then use those zeros to factor. So first thing we should identify is the degree in the polynomial function. The degree is the biggest exponent, which we see as 3. Since the degree is 3, we know there are at most 3 real zeros. And that's because the degree is 3. So the degree will always tell you the largest possible amount. It doesn't necessarily have to have that amount of zeros, and we'll see that in one of the future examples. So when we're looking for these zeros, we need to first identify what the possible zeros could be. So we want to start off looking at the constant term. The constant term is just the number, which in this case is -6. And we want to look at the leading coefficient. The leading coefficient is the number attached to the term with the biggest degree. So we said the biggest degree was 3, so we're looking at this term, and we're looking at the number attached to it. So the number there is 1. So using the constant term and the leading coefficient, we want to find the factors of each of those. So we start off with the constant term, which is designated as P. Again, we want to list the factors of -6. Factors are two numbers that multiply to the given number. So one set would be 1 and -6, because 1 times -6 gets me to -6. Another set would be -1 and 6, because multiplying those two values get you to -6. Then we also have 2 and -3, as well as -2 and 3. So writing these factors in order, just because I like everything to be nice and neat, I have a +1, a -1, a 2, a -2, a 3, a -3, a 6, and a -6. These are all the factors of the constant term. So once we have our factors of the constant term, next thing we want to identify are the factors of the leading coefficient. And that leading coefficient, those factors are designated by Q. So we're finding the factors of 1. Again, what two numbers multiply to give you 1? We have 1 and 1. And we have -1 and -1. So the factors of 1, again written in order, are 1 and -1. And I'm not going to write the repetition of -1, writing it twice. I mean, -1 is still a factor and it's written there. Once you identify your factors of the constant term, which was -6, and the leading coefficient, which was 1, you next want to divide those factors. So we're doing P divided by Q. Let me change the color here. So I want to take each of the factors of P of -6 and divide by each of the factors of Q. So 1 divided by 1 is 1. 1 divided by negative 1, negative 1. Negative 1 divided by 1, negative 1, which is already written. Negative 1 divided by negative 1, positive 1, which is already written. Next thing we have 2 divided by 1, which is 2. Then we have 2 divided by negative 1, which is negative 2. Negative 2 divided by 1, negative 2, which we already have written. Negative 2 divided by negative 1 is positive 2. We continue this process until we've divided all of the factors of negative 6 by all of the factors of 1. So continuing through the process, we'll get 3, negative 3, 6, and negative 6. So these are all of the possible zeros that would exist for this polynomial function. These values aren't necessarily zeros, but these are the possible zeros. So now we need to check to see which of these actually are zeros. So in order to do that, we're going to use the remainder theorem, which was talked about earlier in this section. The remainder theorem says that if we take a value we think is a factor and we plug it into the function and we get an output of 0, it is a factor. So what I'm going to do is I'm going to check f of 1, I'm going to check f of negative 1, I'm going to check f of 2, and same thing with the rest. So I'm checking each of these values. So all I'm going to do is I'm going to plug each of these values into the given function. So let's start off with f of 1. So notice I'm going to use my calculator. Feel free to do this in your head if you want. So wherever I see an x for f of 1, I'm going to plug in a 1. So I have 1. Inside parentheses, I have that 1 raised to the third. Then I have plus, that is a plus sign there, 2, and then in parentheses I have 1 squared. Then I have minus 5 times 1 minus 6. And notice you can type it in all at once. There's nothing wrong with doing that. It gives me a value of negative 8. So I know f of 1 is negative 8. I'm going to go through and find each of these values. I'm going to find each of these values by plugging in the x value. So instead of retyping this each time, I'm just going to re-enter what I already had entered. And I'm going to insert a negative in front of each of these 1s. Oops, I deleted that, so I'm going to have to insert. Let's make sure I do it right this time. I messed up. Let's just start fresh. 1 with a negative 1 in parentheses raised to the third power plus 2 with a negative 1 in parentheses squared minus 5. Ooh, man, I'm having a rough time. Minus 5 times negative 1 minus 6 gives me a value of 0. So I know f of negative 1 is 0. So is there a shortcut on how to type each of these into your calculator without having to retype it each time? There is. You can type it each time. There's nothing wrong with that. I'm going to show you the shortcut so you're at least aware of it. So what I'm going to do is I'm going to go into my y equals button, and I'm going to type in the original function. So x cubed plus 2x squared minus 5x minus 6. Notice how it's written in y1. So what I want to do now is on my main screen, so I'm going to quit out of here. I want to enter y1 and then enter it just like it's written here. So y1, you'll get to that by hitting vars, going over to y-vars. And remember, this was a function, so we're going to choose function. There is y1, which again I'm choosing. And then just in parentheses, I can put the 2. And it will evaluate that function I typed in y1 when x is 2. So I know f of 2 is 0. So again, I'm going to try negative 2 now. So vars, because already in my y1 I have the function, I'm going to vars, y-vars, function, choosing y1. Ooh, not in there. Let's change that back to an x. On my main screen, I'm going to go to vars, y-vars, function, y1, and then type in the negative 2. So when x is negative 2, my y, or my function, is 4. Again, I'm just going to continue this process for each of them. And you can plug these in individually if you would like. So y1 of 3 is 24. And then in interest of time, I'm going to just enter these values that I found previously. F of negative 3 is 0. F of 6 is 252. And then f of negative 6 is negative 120. So these are the values for each of the possible zeros that could exist. So now we need to determine which of these are zeros, if any of them are. The remainder theorem says it is a 0 if the outcome, or the output, is 0. So we have 3 values where the output is 0. So there are my 3 real zeros. So my real zeros are negative 1, 2, and negative 3. Now we need to use those zeros to factor. Since we have all 3, remember the most we could have are 3 real zeros. Since we have all 3, it's very easy to factor. All we have to do is kind of plug it in backwards. I know one factor will be x minus one of the zeros, which was negative 1. I know another factor will be x minus 2, which is one of the zeros. And then I know my third factor will be x minus negative 3, which is the third zero. And then just to make it look pretty, let's change those minus and negatives to positives. So my factored form is x quantity x plus 1 times the quantity x minus 2 times the quantity x plus 3.